Problems 8 through 13 cover the matching section, and I start by just solving these as if I were to solve any other equation. So on this first one, I will be adding 3 to both sides. And that will give me 10 is greater than or equal to x over negative 2. Then I will be multiplying by negative 2 to cancel that from the bottom. Do that to both sides. Now, while I do this, I just multiplied by a negative number. So I'm going to go ahead and flip my inequality symbol down here. And these will cancel. And that will leave me with negative 20 is less than or equal to x. And I'm not sure which graph it matches to. I don't remember the letter, but the number line, it will look something like this. You have 0, then you've got negative 20, and it'll be a closed circle on negative 20, and it's going to say negative 20 is less than or equal to x. Well, negative 20 is less than 0, so I know I will need to shade to the right. So you have a closed circle on negative 20, shade to the right, and that will be which one you match it with. We're going to do the same thing here on number 9. We are going to just solve it like we were to solve any other equation. So we'll plus 1 on both sides. That'll give us x over 3 is less than or equal to 5. Then from here, again, we're going to want to clear our fractions. So we'll multiply times 3. That'll cancel. We'll multiply times 3. You don't flip it because it's not a negative number. And that leaves you with x is less than or equal to 15. I can quickly graph that. I'll put 0, I'll put my other number. You really only need your 2. And then on 15, I know it's going to be a closed circle because it's less than or equal to. And that arrow points to the left, but it's also, I know that if I were to test out 0, 0 is less than or equal to 15. So I know I can shade to the left. The arrow rule, this rule right here, it only works when the variable comes first. On problem number 11 here, this is a really quick and easy problem if we just look at it as if it were an equation. So I will start by subtracting 3 because I want to get x by itself. These will then cancel, and that will give me 2x is greater than or equal to 4. Now, I'm going to just, again, I want to get x by itself, so I'm going to divide by 2. What you do to one side, you got to do to the other. And you don't flip it, it's a positive number. So you're just simply left with x is greater than or equal to 2. And then we've got our number line. You've got 0, you've got 2. It's a closed circle because of the x is greater than or equal to 2. And I know, again, my arrow rule, it's going to tell me to go to the right. But I also know that 0 is not greater than or equal to 2, but 3 over here is. So I'm going to shade to the right. And that's it. And then we've got problem number 10 here. I will start by adding 2 on both sides. I'm always wanting to get the x by itself on one side, and to me the quickest way to do so would be to add 2 to both sides, and that leaves me with 5x is less than 10. I then know just to divide by 5, that'll clear those. Divide by 5, x is less than 2. And then I will just do my number line again. 0, 2. Now on 2, it's going to be an open circle this time because it's just less than. It's just less than here. Then I'm going to say, okay, I'm going to test out 0. Is 0 less than 2? Yes, it is. So I know because this is less than 2, I then will shade to the right. Or to the left. Not to the right. To the left. To the left. And our little arrow rule. So we know that's telling us to point to the left. Problem number 12 here. I just realized these are out of order, but that's okay. We can just add 7 to both sides. Add 7. That leaves me with 9 is less than 3x. From here, again, we're just going to get 3 by itself. Or get the x by itself by dividing by 3. Those will cancel. And that leaves me with 9 is less than, oh, not 9. That leaves me with 3 is less than x because 9 divided by 3 is 3. Zero, 3. Now it's telling me 3 is less than, I'll test out 0 for x. Well, 3 is not less than 0, so I know it's not going to be shaded to the left. I'm going to put an open circle at 3, and I'm going to say, okay, 4. 3 is less than an x value of 4. True. So I'm going to shade this way. If I wanted to do my arrow trick, I'd have to do the flip-flop rule, and that is, if I flip-flop my numbers, I have to flip-flop my inequality symbol. I like to think of it almost as if the inequality here is eating the x. If I go to flip the numbers, it's also got to be eating it over here. It's the same thing. Put an open circle and shade to the right. This last one here, we're going to start off by subtracting 6 from both sides because I want the x here, I want to isolate the variable. So I'll do that by subtracting 6, subtracting 6. Inequality symbol stays the same, it just becomes 5x is greater than 5. We know just to divide by 5, and we're left with x is greater than 1. Really quick and easy to graph. So at 1, we have an open circle. I'm going to test out 0 over here. Is 0 greater than 1? No. Okay, 2 over here. Is 2 greater than 1? Yes. So I need to shade those true solutions, and I do that by shading to the right.